In 1995, Philippe Cruchton developed a model that lets architects break down and look at a system according to 5 different views, and this is called the 4+1 model. When you're trying to look at something as large and complex as an entire system architecture, it's useful to be able to break down the whole into sets of related parts. You can use the 4+1 model to understand the role that each kind of UML diagram plays in the model that you're creating as a whole. As you can see here, the model depicts 5 views: the logical view, the process view, the physical view, the development view, and the use case view. These views of the system are concurrent, and each offers its own significant perspective on the system architecture. The use case view in the middle there is the +1 because, unlike the other 4, it shows the system's functionality from the viewpoint of the outside world. Each of these views represents one aspect of the system, and each has particular kinds of UML diagrams associated with it. We'll look at each view in turn. Let's start with the logical view. The logical view shows the parts that comprise the system as well as their interactions. It represents a set of abstractions, emphasizing classes and objects. So you could say that the logical view describes the system's object model. UML diagrams that show the logical view include these. Class diagrams, and class diagrams, by the way, are by far the most common kind of UML diagrams, so you'll be seeing and working with these a lot. Also state diagrams, object diagrams, sequence diagrams, and communication diagrams. Each type of diagram has its own set of movies. Next is the process view. This view describes, not surprisingly, a system's processes. The process view shows any communication between those processes, and it explores what needs to happen inside the system. The process view is particularly helpful when your system will have a number of simultaneous threads or processes. And the UML diagram that represents the process view is the activity diagram. Next is the physical view, and this view models the system's execution environment. The physical view is where you map software artifacts onto the hardware that hosts them. UML deployment diagrams are used to model the physical view of a system. Next, the development view. The development view describes the system's modules or components, including packages, subsystems, and class libraries. This view gives what you might call a building block view of the system because of the way it looks at modules. And the development view is very helpful in managing a system's layers. UML diagrams that show the development view include component diagrams and also package diagrams. And finally, the +1, the use case view. The use case view shows the system's functionality. In other words, this view illustrates what the system is supposed to do. The use case view captures user goals and scenarios, and it offers an outside world perspective on the system. The use case view is helpful in defining and explaining the structures and functionality in the other 4 views. So this view, the +1 view, provides a guide for the models in the other 4 views. UML use case diagrams, along with written use cases and requirement specifications, provide the use case view. The 4+1 model is important because it helps you make sure that you've considered and documented all the important aspects of your system.